Hi girls, let me practice with you some of past exam questions on enthalpy and thermochemistry. Question 1. Use the periodic table on page 9 to answer the following question. Choose the best answer. Question 1. Use the following diagram to answer questions 1 and 2. Which diagram represents the reaction that tends to be the slowest? Slowest reaction, which is very endothermic. The slow reaction is the endothermic reaction. Why? Because the endothermic reaction, the activation energy is very high. If you compare the activation energy in all of them, you will find that in endothermic reaction, the activation energy is very high. That's why this reaction will be the slowest. Remember here to be able to answer the next question, activation energy here in this graph is 20 from 0 to 20, and the activation energy here is from 0 to 30 in the forward reaction, while in the backward reaction is here it will be 30 plus 10, 40, and here 30. In this reaction is 20, and in this reaction it's 50. Here is the EA for the reversible reaction, which is 50 minus 30 equals 20. So the activation energy for the forward reaction is 50, and the activation energy for the backward reaction is 20. Which diagram has EA 50 kilojoule per mole and EA plus 20 kilojoule per mole? Going back to the previous slide. So in reaction C, the activation energy is 50 and 20. Next question, the minimum amount of energy needed to form an activated complex is known as, to form the activated complex is the activation energy. Next, if the collision between two molecules is very gentle, means very simple collision or very weak collision, so the molecules are more likely to rebound without reacting. They will not react because they need enough collision or enough amount of energy on collision in order to react. They reacted in bound, no. Less likely to be favored oriented, even though it's correct, but because the molecule have very gentle collision, so it's more precisely to say that they are rebound, mean that they are going to collide, but without being reacted. A substance that speeds the rate of reaction without being used up is the definition of catalyst. 6. The energy of the activated complex is higher or lower than energy of reactant and also higher or lower than energy of products. Let's look at the graph to be able to answer this question. As you know, wherever the reaction is exothermic or endothermic, the activated complex will be at the top. So if the reaction, for example, this reaction is an endothermic reaction, and if it was exothermic, it will be also like this, but it will go down. So in all cases, the activated complex is at the highest point. So the activated complex has energy higher than that of the reactant and that of the product. This question, according to the collision theory, for a reaction to occur, the colliding substance must collide with sufficient amount of energy to form the product directly. This is correct. They should have enough kinetic energy to react. Secondly, the reacting molecules should be in the correct orientation. So the answer will be 1 and 2 only. We didn't put 3 must collide with sufficient energy to form an activated complex. This is not necessary. A reaction with faster rate at room temperature is always exothermic reaction or has a small activation energy or has large activation energy. The reaction which happens faster at room temperature means the activation energy should be very small. But not necessary for this reaction to be exothermic or endothermic. Okay, but just we know if the reaction happens at room temperature, means that the activation energy should be very small. Next, the value of delta H for an exothermic reaction is always negative. Yes, that's true. Look at this energy level diagram. You are asked to label to identify each part of the graph. As you know, B is reactant and E is product, D is activated complex. The difference between reactant and the product is the enthalpy change of reaction. The distance between reactant and the activated complex is the activation energy of the forward reaction. C could be the activation energy of the backward reaction. Because if the reaction is reversed, the product will be reactant, and here the reactant will be product. So the distance between reactant and the activated complex will be the activation energy for the backward reaction. Which is slower, forward reaction or backward reaction? Justify your answer. If you look at the reaction, if the reaction is exothermic reaction, this means that the forward reaction will be faster. Going to the graph again, you can see here that the activation energy of the forward reaction is much higher than activation energy of the backward reaction. This means that the forward reaction is not favored and it will be slower. In any graph, when you see the activation energy is high, this means that this reaction should be slow. Then, is this reaction exothermic or endothermic? By looking at the graph, okay, the curve was going like this. This means that the forward reaction was endothermic, and that's because energy products is higher than energy of reactants. Calculate energy change for the reaction, for the forward reaction, going back to the graph. Enthalpy change of the forward reaction is the distance between reactant and the product. So now you need to calculate this value. This value is 80 minus 20. Enthalpy of products minus enthalpy of reactant. So it's 20. Sorry, the product has enthalpy of 80 and the reactant has enthalpy of 20. 80 minus 20 equals 60 kilojoules. On the same diagram, sketch the pathway of reaction after the catalyst is added. This part is not required. Explain all possible reasons why collision between two reacting particles don't always yield a product. In order for the collision to yield a product, enough energy is required and the correct orientation is also required. Which of the following collisions resulted in a reaction? If you look at the collisions, here a collision happened between in A between those two particles and in B. But what happens is if nothing happened, because after the collision the reactants stay without any change, because here this one is before collision and after. We can't see any change here or there, before and after. But in C, you can see that they produce an intermediate compound, which we call it activated complex, and then they produce useful product. This problem is about bond enthalpy. You are asked to use the bond enthalpies values given here to calculate enthalpy of the following reaction. 2H2 plus O2 gives 2H2O. Let's get started. You know first the value of a bond enthalpy. To calculate bond enthalpy, you need to find the sum of enthalpies of bonds broken minus sum of enthalpies of bonds formed. Looking at the equation, you have the bonds given to you. Okay, I have here 2H2, so you need to multiply this value by 2. For O2, you will use it as it is. And for H2O, as you know, this is the equation to show the bonds. The product will be 2HOH. Means that I have each water molecule has two OH bond, 1 and 2. And this will be multiplied by 2, means that the bond OH, the enthalpy bond OH will be multiplied by 4. Now it will be very simple to calculate the bond enthalpy. So first we'll calculate the bonds broken, and here bonds formed. For bonds broken, the bonds in reactants are broken, right? So those bonds are the ones that are going to be broken. The bonds formed will be in the product. So here is the bonds formed. So the sum of bonds broken energy will be 436 into 2 plus 499. The sum of bonds formed will be 463 into 4. Get the values and subtract. You will find that the correct answer is minus 481 kilojoules.